Yeah, okay, 6:30. Yeah, 6:30 sound good to you guys? Try to get as much done as we can by 6:30. And then whatever we don't finish, we'll just finish on Tuesday. All right. So we will start with homework. Who has questions on the homework? And this is for any topic that's for exam 2. So that's starting from, let me pull up the syllabus. So 6.3, which was partial fractions, all the way to 8.3, which is integral test. Question 4. You're gonna have to give me a like a section. Oh, are you talking about the review sheet? Yeah, I mean, yeah, we'll go over the review sheet, but I kind of want to go over the homework first because I assigned all the homeworks earlier. So, but yeah, I'll keep question 4 in mind when we start the review sheet. So, who has questions regarding the Lumen homework? Question 11, how do you compare it to a series? Could you just let me know what section that is so I can pull it up? 8.3, okay. Question 11, let's see. All right. So here's question 11. So this says, use the comparison test to determine whether a series is convergent or divergent. Okay, well, this one forces you to write the formula for the series first. So were you able to do that? Like, were you able to write it in summation notation? One over n squared. Yeah. 1 over n squared. 1 over n squared is convergent, isn't it? Yeah, I'm pretty sure you don't even need to compare it to anything. Yeah, I don't know why this question wants the comparison test. You don't really need to use the comparison test here. So this is convergent. All right, Yosef says question 4. So Question 4 says, use the comparison test. Okay, so the part where you write the limit, are you talking about this part right here? Okay, so since this series satisfies the conditions for the integral test, we can, well, first thing you have to do when you do the integral test is you have to integrate it. So we're trying to integrate 5 over x to the 9th. So that would be x to the, so right now it's -9, so you add 1, and then you divide by that. So carry the 5. If you write this, I think that's what they want. You don't need to use the variable b yet because they have it over here. So they're saying the integral is going to be this evaluated from 1 to b. Yeah, hopefully that cleared it up. All right, anyone have anything else? Question 15. Okay, yeah, this one. All right, so question 15, actually a student from, or one of the students came into office hours to ask me about question 15. So this question actually requires knowledge from a later chapter. So I can't go over question 15 yet because it's not really relevant to what we know right now. I don't know why they put it in that chapter. So I'm not going to go over question 15. In fact, I think I'm going to have to withdraw it from the homework. So don't worry about question 15 because that one is not something we know how to do from like the regular comparison test. All right, anything else? So you guys have been just asking me questions on section 8.3. I'm assuming that means you guys are all masters of sections 6.3 to 8.2. Is that right? All right, well, I'll give you just a couple more minutes to think about if you want to ask anyone. And then if we have nothing, then we'll go straight to the review sheet. Previous question, it was not a harmonic series because it was a 1. Let me see. What was the previous problem? So the previous problem was 1 over n squared. No, that's not a harmonic series. A harmonic series is 1 over n, not 1 over n squared. I think. Yeah, okay. So we'll go straight to the exam review sheet now. So first request was question number 4. So we'll look at that first. All right, here's question number 4. So this one says, approximate the given integral using Simpson's rule with n equals 4 subintervals. So yeah, for this one, you'll need to remember the Simpson's rule formula. So does anyone remember it? I'm gonna pull it up while you guys try to see if you have it. Recall that Simpson's rule is a method of approximating the answer for an integral. So it's under 6.5, approximating integrals. Okay, so here's the formula. I pulled it from the PowerPoint. All right, so if we were to just make a rough sketch of this graph, here's x equals 5 and here's x equals 9. And then you can just draw a picture of the curve. I don't know what this curve looks like, but it doesn't really matter. So we're trying to estimate the area that's cut off here. So this is what we're trying to estimate, this area here. And we are trying to do it with how many subintervals? With 4, which means we're going to split into 4 different regions. So 1, 2, 3, and then each region is going to be connected with a quadratic. So I don't know if you guys can picture a quadratic. I don't know, it doesn't matter. So if we're using 4 subintervals, then how should I label the x-axis? What x values do I need?
Six, 7,
Yeah, 6, 7, and 8, 9, right? So yeah, and the reason why it's that, it's because our limits of integration was from 5 to 9, and then we're using 4 subintervals. So that's why each one is just a whole number. So likewise, if I was to give you, say, 8 subintervals, then you would go by halves, right? So you would go 5.5, 6, 6.5, and so on. Yeah, sure, Beatrice. Okay, so the formula says we need delta of x. So remember that delta of x is just it's just the length of each subinterval. So that's, we know it's 1, but if you want it to be, precise, it's b minus a over n. So it's 9 minus 5 over 4, which is 1, but we knew that already. So it's 1, and then that's divided by 3, So inside the parentheses goes the rest of your formula. And the formula goes like so. So it's, if you look at the coefficient, it's 1, 4, 2, and then it starts alternating. So 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, and then the last term is going to be 1 again. So it's going to be 1, f of 5, and then 4, f of 6, plus 2, f of 7, plus 4, f of 8, and then this is the last term, so it's going to be 1 again. So 1 f of 9. Okay. So the question is, how do we evaluate these things? What is f of 5 and f of 6 and all that stuff? So that is actually just a function that's given to you here. So you can treat f of x as this function square root of 1 over x cubed. Okay. And then to plug in x equals 5, you would just do 1/3 and then square root of 1 over 5 cubed plus 4, and then square root of 1 over 6 cubed plus so on and so on. And I think you guys get the point of this question. So that would be your approximation for the Simpsons rule. You plug all this into a calculator, and then you would get some answer. Okay. Let me know if you guys have any questions on that. Are you still going to give us just a class time for this test? Yeah, I mean, that's what I did last time, and it was fine. So I'll probably do the same thing. Yeah, I will do the same thing this time. There will be less questions, though, which hopefully will make it better since last test, a couple of students handed in late. All right, what did you want to go over for the PowerPoint? Let me know which chapter. 8.2, page 9, okay. All right, series. Determine if the following series is convergent or divergent. Okay, let me paste it. All right, so yeah, what's your question about this slide? Oh, okay. Then what page? Geometric series. Let's see what page that is. Okay, yeah. How would you find the sum that it says on the last part of the last line? A over 1 minus r. Yeah, so A is the first term in your series, and then r is the common ratio of your series. So for example, if you had a series such as, I don't know, 5 times 1 over 3 to the nth power, or n equals 0 to infinity, then the sum here would be 5 over 1 minus 1/3. If you wanted to write down the series, you can also do that. So the first term in the series is when n is 0. So that would be 5 times 1/3 to the 0 power, which is 5. And then 5 to the 1/3 to the first power, and plus 5 times 1/3 to the second power. So that's your series, like each term of the series written now. But if you want the sum of the series, then that's the formula. Oh, yeah. So yeah, there is a rule for whether it'll converge or not. So here's the rule. It's whether or not the common ratio is less than 1. So it will only converge if the common ratio is less than 1. If the common ratio is greater than 1, then it's going to diverge. And if it diverges, then it doesn't really have a sum. The sum will be infinity if it diverges. And the reason why you need the common ratio to be less than 1 is because if the common ratio was greater than 1, then what happens is the next term is always greater than the previous term. So if you do that, then the sum is never going to be finite. So that's why we need this condition. This is an approximate answer for the series. No, this is an exact sum. A over 1 minus r is the exact sum if you add up all the infinite terms. But I mean, I didn't show you guys a proof of why that's the formula, but I said before that we're going to omit proofs because I don't think any of us want to see it. Yeah, so this is an exact formula, exact sum. All right, so what do you guys want to go over next? You can ask me, questions on PowerPoints, or we can go back to the review sheet. Yeah, so for question 4, back to the Simpsons rule question, the directions does say to round to 2 decimal places. So yeah, I will specify on the exam what I need you to round your answers to. All right. Any particular order you guys want to do the questions now? If not, then I'll just go from 1, 2, 3, and so on. All right, so let's try to do number 1 on the review sheet. So this one says, use the integral test to determine whether the following series converges or diverges. Assume that the prerequisite conditions for the integral test are satisfied. So remember, for the integral test, you have to make sure that it's, number 1, it's continuous. And then number 2, it's decreasing. And then number 3, it's always above the x-axis. So here, I mean, you're supposed to check it, but the directions tell you to, you can skip checking those conditions. So we don't need to do all that. Instead, you can just jump straight into the integral test, which says to find the answer to the series, you can just integrate it instead of doing summation. So this would be 2 to infinity of 1 over 2n plus 7 to the 3rd power. I wrote n, so dn. Okay. So these questions are always going to be given to you where you can integrate it once you turn it into an integral. So who knows how to integrate this? U sub 2n plus 7. All right. So that means du is 2 dn. Yeah, I think we'll do that eventually. So it's 1 over u to the third right now. And then dn is du over 2. And then you can rewrite this as u to the negative third power du. So then when you integrate, you get u to the negative 2 over negative 2. And then now we can put what u was back in. So this is 2n plus 7 to the negative 2 over negative 2. Recall that we have to evaluate this from 2 to infinity. So because we need to do that, now let's try to just write our answer more neatly so it'll be easier to evaluate. So this is equal to, I'll write it as 1 over negative 4 2n plus 7 squared. And then we're evaluating this from 2 to infinity. So keep in mind that this was an improper integral, right? Because the limit was infinity. So you have to take the limit as a variable goes to infinity of 1 over negative 4, 2t plus 7 squared minus the bottom limit. So that's negative 4, 2 times 2 plus 7 squared. Okay. So is this convergent or divergent? Can we tell yet? Yeah, convergent. Because the first term goes to 0, right? Because the denominator goes to infinity, so the first term goes to 0. So we get just the second term, which is positive now. 4 times 2 plus 7 squared. Okay, so that will be the answer to your integral, which means our series is also convergent, and it converges to this value. So this is converges to this number here. All right. Is everyone okay with that? Yes, okay. You know, like how some professors, they ask you, does anyone have questions? And then they give you like 0.2 seconds to answer before they move on. All right, let's do number 2 since I don't think you guys have a preference on the order. Okay, so number 2 says evaluate this integral. Yeah. All right. So one of the main struggles of this class when taking exams is you'll be faced with a problem and the directions is tell you to solve it, right? But you won't necessarily know like what method you need to use. So part of the studying process is being able to tell um, what methods you'll need for a particular problem. So for this one, can someone say what method is appropriate and then explain why?
Partial fractions,
Okay.
because like we could see like it already has a factorized denominator, which kind of tells us we could divide it. Like you can see the formula and think of like how we divide the denominators. And I don't know, right? It was just because the denominator is factorized to the lowest power of x.
Yeah, I mean, yeah, that's pretty much it. Very good. So whenever you have a integral where the denominator is factorable, just go straight to partial fractions. So, um, well, before you even start partial fractions, you guys remember what was the first step?
Power of the numerator has to be greater than the power of the denominator,
Um, well, it doesn't have to be.
or equal or something, right?
Uh, Something like that. Let me see. Someone wrote something. Degree of denominator compared to degree of numerator. Yeah. So what do you do? So in this case, it's equal. So you guys remember what you do in that case? So the degree in the numerator is 2 because it's x squared. The degree in the denominator is also 2 because you have x times x, which is x squared again. You want to say integration by parts because you said it once, so we just said integration by parts. Um, I don't think anyone said integration by parts, but well, there's
Talking
one
about
reason why we wouldn't do integration by parts, and it's because that's part of exam 1. But yeah, you're gonna say something?
Now, I think he was talking about your former student who evaluated all the integrals using the integration by parts formula.
Oh yeah, yeah. But that's only for those like easy integrals that you can do without it. Like you just need to add 1 to the exponent or whatever. But he would use integration by parts for that. But no, you can't do that here. Um, so you do need to do long division here, and the reason is because uh, the the degrees are equal. Do you guys remember the situation where you can actually skip doing long division? Yeah, so only if the degree in the numerator is smaller than the denominator is when you can skip doing it. So here it's not. So unfortunately, we will have to do long division. All right, so we have to divide this stuff. So this is 6x squared plus 3x. And then we're dividing that by, I'm gonna have to multiply these out because you need to have it all in like one pair of parentheses for long division. So this is x squared uh, plus 2x. How do I do this? Minus 8. Okay. So for long division, you have to just divide the leading terms. So 6x squared divided by x squared, that gives you 6. Okay, and then 6 times your divisor. So I'm going to distribute this to the divisor. Oh yeah, sorry. Yeah, I feel like I would fail my test if I took my test because I would just make all these mistakes. So I'm going to multiply 6 to the divisor. That'll give you 6x squared plus 12x minus 48. Okay, and then we have to subtract this. So the first term should always cancel out. And then you have negative 3x minus 12x, which is negative 15x. And then 0 minus negative 48, that's plus 48. Okay, so at this point, you see that the remainder has a degree of 1. Right? The power here is 1, which is a degree less than the divisor. So you can actually stop here. You're done with long division. So we can rewrite our integral as the quotient plus the remainder over our divisor, which was x minus 2, x plus 4. Okay, so yeah, make sure you do need to do you do review how to do long division, just in case I give you one that requires long division. All right, so now we have the situation where the degree is less than the denominator. So you can go ahead and do partial fractions now. Six plus, okay, so I have x minus 2, x plus 4. Okay, so now we need to find what the numerators are, right? We just call them a and b. Did anyone find a and b? For those of you who did the review sheet, I think someone found it. No, no one found it. All right, so let's find a and b. All right, so to add the two fractions, you have to just find common denominators, which mean you have a times x plus 4 plus b times x minus 2 equals the original numerator. So that's minus 15x plus 48. Okay, so here it's probably easiest just to find a and b by choosing very particular values of x. So what are the convenient values? Let x equal 2 and negative 4. Yeah. So when x is negative 4, that means the first term goes away. So you'll just have negative 6b is equal to, that's positive 60. So it's 108, which means b is 108 over negative 6. Okay, so that's b. And then the other convenient value of x was 2. So that gives you 6a is equal to negative 30 plus that's 18. So that means a is 3. All right, so I found a and b. So remember what I said about like how I'm not gonna make finding a and b a hard task. So don't expect to be solving like a system of equations with like 4 equations or anything. It'll probably be 2 equations, just like what we have here. So let's rewrite our integral. So a was negative 108 over 6, and then, oh no, wait, that's b. B is negative 18. Okay. Yeah, so this is 3, this is negative 18. Okay. At this point, you should be able to integrate these without much difficulty. So this is 6x plus 3 natural log of x minus 2 minus 18 natural log of x plus 4, okay, plus c. So do be careful on the natural log parts. I was able to just do these normally because the coefficients of the x was just 1. So it was a 1 here and it was also 1 here. But if they were not 1s, then you would have to sort of do a u substitution, and then you would have like a constant over here, okay? But here we didn't have that, so this is fine. All right, any questions on partial fractions? All right, moving on. You could have pulled a 3 out of the integral. Oh yeah, we could have done that. Yeah, that would probably change your a and b values, but your final answer should be the same. Yeah. Okay, so here's question 3. This says determine whether the following sequence converges or diverges. So again, remember the difference between sequence and series. So for sequence, you're not actually adding all the numbers. It's just a list of numbers. So this is just the formula for each number. Okay, so here we have a sequence where n starts at 1. So did anyone try doing this? Okay. Um, Anyone want to try and guess what a good first step might be? do comparison tests and hope it diverges. Uh, there is no comparison test for sequences. So comparison test, we only did it for integrals and series, but not sequences. And there was actually only one way that we learned how to deal with sequences. I don't know if you guys recall, but the way we dealt with it was you just treat it like a function. So instead of thinking that this is a sequence, which is fine, you can just pretend it's like this. So if you have f of x equals e to the 5n, not 5n, 5x over 3 minus e to the 2x. So if you have that function, we need to take the limit, right? Because that's how we find out if it converges or diverges. So what happens to this function as x approaches infinity? So limits as x approaches infinity of this function, which is good because we have a lot of techniques for how to find the limit of functions. So you got diverges. Okay. Can you walk me through your work?
I just took the e to the 5x and then just divided it by the negative e to the 2x because that's how we did it in high school to find the, I think, vertical asymptote.
Okay, so you just divide every term by e to the 2x. That's fine. So you will have e to the 5x divided by e to the 2x. And in the denominator, this is 3 divided by e to the 2x. So like this.
Yeah, I think so.
Okay, that's fine. So then when we simplify this, we will get,
I think it's supposed to be negative e to the 2x. I'm not sure if that makes a difference.
I think this is fine because if you leave it positive, then the one on the bottom right will cancel out. So this will be e to the 3x now. And then this is 3 over e to the 2x. And this is just 1. So we can take the limit now, actually. You guys see what you get when you take the limit as e approaches infinity? So this is a -1, that's fine. What does this go to as x approaches infinity? 0, right? Yeah. So, and then what does this go to? Yeah, that goes to infinity. So we have infinity over 0 minus 1, which is infinity over -1. So that's negative infinity. That's diverge. Yeah, does that have anything to do with the asymptote you were talking about, or no?
Yeah, that's everything I did. You just like kind of dragged it out a little, but in high school we just like did that without the step you did.
Okay, all right. That's fine, yeah. So there's many different ways of doing this. Another way that I can think of is you can use L'Hopital's rule if you wanted to, right? You can take the derivative of the top and bottom. That'll also get you to negative infinity eventually. So yeah, for sequences, just make sure to consider it as a function and then go from there. Any questions? Looking at the board, looking at you guys. All right. So we just did, what number was that? That was number 3. So we did 1, 2, and 3. We did 4 as well. All right, it's about 6:30. So I think we'll just stop here for today. We'll go over the last 2 questions on Tuesday. Is that okay with you guys? Yep, okay. All right, so that's all for today, guys. I'll see you on Tuesday. Have a good weekend. Good luck studying. All right, class dismissed.
Thank you. You have a great day too.